Hey YouTube, welcome back to Science Talks. I'm your host, Foxtrot. Today we're going to talk about how scientists are using parasites to fight each other and combat drug resistance, how positive reinforcement boosts your immune system, how people are using pee to power light bulbs, and a wristband that tells you when you've been drinking too much. So first up, we have using parasites to fight each other and get rid of drug resistance. So Nina Wales of the University of Michigan has shown that the drug-resistant malaria strand, Plasmodium chabadi, can be outcompeted by the non-drug-resistant strands. So if you don't know, the way drug resistance works is that you give somebody medicine to try and kill a pathogen, but it doesn't kill all of the pathogens, and the pathogens that survive last and reproduce and pass on their genes that allow them to survive to their next generation, thereby creating a whole bunch of pathogens that are immune to whatever drug you tried to use initially to kill it. So what researchers did is that they gave mice 1 million parasites of the Plasmodium chabadi that I mentioned before that were resistant to a drug known as pyrimethamine. They also gave the mice 100,000 strains of the parasite that were susceptible to the drug. And what they saw was that the susceptible parasites were able to keep the drug-resistant parasites in check and keep them from blossoming into larger numbers. So researchers took it one step further. They know that strains of P. chabadi need a compound known as PABA in order to synthesize DNA. But they also noted that the drug-resistant strain needs it more than susceptible strain. So they noted that if the PABA compound was not provided to infected mice, the drug-resistant strain of P. chabadi died out much faster than the susceptible strain of P. chabadi. So essentially what this means is that researchers were able to create a competitive environment for these pathogens in which they noticed that susceptible strains were able to outcompete the drug-resistant strains. Now this could be a useful strategy in eliminating drug-resistant pathogens from humans, but it has a lot of problems still. Like, you would still, I guess, technically have to inject them with more of the pathogen and hope that they can outcompete each other, and you would still need to use drugs to get rid of the now susceptible strain, so drug resistance could just arise again. However, it is interesting research in a step towards trying to get rid of drug-resistant pathogens. So our next story provides a potential explanation for the placebo effect, where scientists noticed that a boost in a mouse's reward system also correlated with a boost in the mouse's immune system. So if you don't know what the placebo effect is, it's just a beneficial effect of a placebo treatment that cannot be attributed to the placebo treatment itself, and therefore must be attributed to the patient's belief in the placebo's treatment. So basically, it's a positive effect that should not have happened because what you gave somebody shouldn't have actually done anything. So what scientists did is that they took mice and activated their ventral tegmental area, which is an area in the brain that's responsible for the rewarding effects to an organism. So after that, they infected the mice with E. coli and found that the mice that had that area of their brain activated had less E. coli in their systems than mice who did not have that area of their brain activated. So these results suggest a connection between the reward system in the brain and a boost in the mice's immune system. So there hasn't been an explanation for the placebo effect yet, but I think this research describes an interesting mechanism for how the anomaly might work. It'll be interesting to see what they do next to try and solidify whether or not this is actually what the placebo effect is. So next up, we have some innovative researchers from the University of West England that have managed to make a microbial fuel cell that converts human urine into electricity. Now, microbial fuel cells are just like normal batteries, except that they use the metabolism of bacteria in order to create the molecules needed to power the battery that they're in. So these fuel cells were tested twice, one at the Glastonbury Music Festival and the other time being on the university campus. And both times, these fuel cells were able to generate enough power to light the light bulb that was in the bathroom facility. So the end goal for these researchers is to send these fuel cells over to developing countries to help improve safety around sanitation facilities via improved lighting. I think this is a really good application for the technology, as it could go a long way to helping these countries. So our last story of the day is a wristband that can detect how much you've had to drink and tell you when you should stop. So the prototype wristband called the Skin is from a company called Backtrack. And what it is a wearable biosensor that detects ethanol molecules that diffuse through your skin, and from this it measures your blood alcohol content. So this information is sent to your phone via Bluetooth, and a warning is sent to you when you've reached half the legal limit to operate a vehicle. So I think there's a lot of really good applications for this technology. The first obviously being used for when to know if you've had too much to drink. I think if there could be a way to get people to actually wear them consistently, bars could use them a lot in order to tell for sure when they should cut somebody off. But I think that's the biggest drawback for something like this. It's you have to get people to actually wear them. And for the everyday person, that might be harder than you think. Okay, guys and girls, that's it for this episode. Leave a comment down below about what you thought of these news stories. And if you liked the video, please leave a like. It helps me out a lot. Don't forget to subscribe so that you don't miss the future episodes. And I hope to see you next time.